In this problem, we want to create a 85% confidence interval, and we're going to do this for a standard deviation. Remember, the reason we are creating confidence intervals in the first place is so that we can estimate a population parameter. So we are looking at the results of a sample, one sample, and we want to use that to make a confidence interval for a population parameter. So in this case, we're looking at college salaries, or excuse me, salaries of college graduates. From our sample, we had 74 people. Their mean salary was $49,325, and the sample standard deviation was $11,210. What we want to do is to use this information to estimate the population for the entire population of college graduates, not our sample, but the population standard deviation. In order to do that, we're not going to use what's called the chi-squared table. I mean, we can read about it, and I have provided some brief overviews of the chi-squared distribution, and that is in your e-text as well. But what we're going to do to create standard deviation confidence intervals, again, this is the standard deviation or for the variance, is use StatCrunch. We are not going to use a table, we're going to use StatCrunch. I have copied a picture of exactly what we need in order to create the confidence interval for StatCrunch. We need the sample variance. We need the sample size. We're going to be performing a confidence interval, so we need the confidence level, and that's it. We're not using a table. We're using StatCrunch. So in this example, do I know the sample variance? Not quite. I know the sample standard deviation. What I want to know is the sample variance. And I know to get the sample variance, I can just square the sample standard deviation. So I'm going to do that. I'm going to open up my calculator and I'm going to square 11,210. So I'll take 11,210 and I'm going to square this, and I'm going to hit enter, and I get a very big number. All right, this is a large number. I'm using a graphing calculator, and the graphing calculator, it fits on the screen. If you're using a small scientific calculator, it may not fit on the screen. This may give you maybe 1.256, and then it'll provide you an EE or an E, and then provide an integer. And what that E and that integer is telling you is how to move the decimal point. So in this case, you might see 1.256 and then 1, 2, 3, 4, 5, 6, 7, 8. Something like 1.256 E8. And that E is telling you have to move the decimal point. That's because your calculator screen is too small for this number. So I'm going to write this out. It might take me a few times. 12566. 12566. I'm just going to write this out. 12566. And then when we go back, 4,100. All right. So what is this number? I'm going to just write out the numerals. Okay, this is 125,664,100. That's the sample variance. That's what we need to plug in to StatCrunch. We already know the sample size. We'll plug that into StatCrunch. These are the only two pieces of information that we need. Along with this, we are going to have to plug in 0.85 for the confidence level, and we'll hit compute. So I have StatCrunch available. We could open that up. So to calculate the population confidence interval for the population standard deviation, I'll go under Stat. I'm looking at the variance, one sample with summary. It's not with data, with summary. We already said that the sample variance, let's go back one more time, 125,664,000. Okay, I put in the 125,664,100 as my sample variance. My sample size was 74, and my confidence level was not 0.95, it was 0.85. So I'm going to compute. What they're going to give you is the variance here, and they're giving you the upper limit and the lower limit, but these are in scientific notation. These are in scientific notation. The E8 is telling you have to move the decimal point. So what I'm going to do is I'm going to pause the video a second. I'm going to copy down these numbers and write them over here on the left. Okay, I have written down the numbers. Again, the scientific number here is, or scientific notation, this is telling me how many times I need to move the decimal point. So I'm going to move it 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8. So what this number is going to be is 100760008, and then we have another 0 because that decimal point is moving one more time. So the lower bound is 100,760,080, and this is for the lower bound of the variance. For the upper bound, I will also move this 8. Okay, so I'm going to move this 8 places to the right, and what you're going to get is 162,692, and then 710. 162 million, I'm sorry, 692,710. And this is, again, if you move it 1, 2, 3, 4, 5, 6, 7, 8. If you move it 8 places to the right, this is the number that you get. Now these are the lower limit and the upper limit for the population variance. So the population variance we would expect with an 85% confidence, the population variance to be contained between these two numbers. We don't want as our final answer the population variance, we want the population standard deviation. So what I'm going to do is I'm going to take the square roots of these numbers, and if I take the square roots of these numbers, that would give me the population standard deviation. Okay, so I'm going to put these numbers into my calculator. Let me bring up the calculator screen, maybe move it over a little bit. Whoops, there we go. So we have 100 million. Whoops, I need to hit the square root first. So second square root, 100 million, 760,000, and then 80. You get approximately, that's approximately 10,037.9. So I'm going to say 10,037.9, and this is the lower limit. 10,037.9. And then for the upper limit, let's put that in. So I want to take the square root of 162,692,710. Or I said that wrong again. 162,692,710. And when you put that in your calculator, you get about 12,755.1. 12,755.1. Now what I found is the most confusing parts about these problems, just these in general, these problems, is realizing that we need to square the value of the variance to put that, or excuse me, square the value of the standard deviation to put that in for the variance. Then what makes this problem extra confusing is that we had scientific notation. So this was telling you 1.007 and so forth times 10 to the 8th power. So move the decimal point 8 to the right. And that's because they don't have space in those small places there to put commas and have it fit on the screen. So what we get is we are 85% confident that the true population standard deviation is contained between these two values of 10,037.9 and 12,755.1. We are 85% confident that the true population standard deviation is contained in there.